I'd love to see your guys' faces, but you don't have to, okay?
Bet. One sec. I gotta get it set up. I have it unplugged.
Yeah, you're good. Okay. Blood lipoproteins. Like I said, we did the cholesterol right before this. That is uploaded. It just finished processing. It took like 4 hours to process to upload into YouTube, but that's there. And then this one I'll upload as well afterwards. And I'll also go ahead and as soon as we finish going through these questions, I'll upload them into the chat with all of like the extra stuff that we add onto them, so that you guys have them. Sound good?
Yep.
Okay, we're gonna start through, and there is a little bit of overlap from this one, from the cholesterol stuff. So, Chris and Elizabeth, help us out as much as you can, and we'll get through them. Okay, a 7-year-old boy is referred to a specialty clinic because of digestive problems. He often experiences severe abdominal cramps after eating a high-fat meal. If we see that high-fat meal, what organ pops into our brain when we talk about eating fat?
Gallbladder.
Yeah, our gallbladder. So he is worked up and diagnosed with a genetic defect resulting in a deficiency of lipoprotein lipase. What does lipoprotein lipase do? What does a lipase do?
Breaks the fat down.
Yeah, breaks down what?
Lipoproteins.
Lipoprotein. It breaks down fats. Fats, protein, stuff that's all together like that. Which of the following substances would most likely be elevated in this patient's plasma following a fatty meal? And let me actually really quick, because I didn't do what I was supposed to do before this, and make a whited out copy of all of this. I'll go ahead and, while I do that, look at the question and tell me what y'all think.
Kilomicrons.
Support your answer with reasoning. Why kilomicrons?
Because you use kilomicrons to basically transfer the fat that's in the intestines into the bloodstream.
Yeah, exactly. So which substance will most likely be elevated in the patient's plasma following a fatty meal? So after we eat all the fat and everything, kilomicrons are what's going to be transporting that fat. I'm going to stop sharing for 1 sec just so that it's quicker for me to white out this way. Good handful of these questions are pretty quick answers, and a handful of them honestly are just kind of memorize-y. So when we get to those, we'll just kind of fly through those. Elizabeth, you have you've been keeping up with the Quizlet, right, with all of these questions in it?
Yes.
Would you mind sharing that in the chat?
Sure can.
As well, if that's okay?
Absolutely.
There we go. Come on, computer. There we go.
I just realized I have my camera on. I'm mouthing the lyrics to the song that's playing on the radio.
Come back. Okay. Sweet. So like we said, whenever we eat the fatty meal, and honestly, this question is kind of a perfect example of all the wordiness that is completely unnecessary. Realistically, to answer this question, all we need is this last sentence. Which of the following substances would most likely be elevated in this patient's plasma following a fatty meal? So, kilomicrons. Okay. Sweet. Okay. Question 2. A certain pathological condition caused decrease in LDL receptor biosynthesis. What may happen if this LDL receptor biosynthesis is severely decreased? So we have a decrease in LDL receptors, right? What would we see happen in the body? Decrease in plasma cholesterol, increased fatty acid biosynthesis, rise in LDL levels, or rise in triacylglycerol biosynthesis?
Rise in LDL.
C,
Yeah, so we're looking to sense the amount of LDLs because we want a specific amount of LDLs in the body. And if we don't have the receptors, actually being produced, then we can't tell exactly how many we have in the blood. So we're going to increase our LDL level to hopefully have a chance of hitting those receptors to make happen what's supposed to happen with those receptors finding LDLs. This next stuff, this is kind of our memorizing stuff where we just have to literally know some of this. Let me see if I can find the part where it talks about this. Here we go. So some of this is literally major apoproteins of the chylomicrons. Apoproteins, these are just going to be specific proteins that are found within some of our different lipoproteins. So chylomicrons, they're ApoB48, ApoC2, and ApoE. So ApoB100, we looked at the ones that are in chylomicrons. None of those fit with the one in chylomicron. That 100 is going to be in our very low density lipoproteins. Unfortunately, these are just kind of memorize-y. It's just use the Quizlet, look at these questions, fly through them 4 or 5 minutes, so you start to recognize what goes with what. Or if you want to, you can come into the book and go through these and make yourself a little chart of exactly like what goes with what. Okay. Chylomicron remnants are produced by addition of ApoE to nascent VLDL, by addition of I think it's supposed to be phospholipids, not lipids, by LDL receptor mediated endocytosis process. That's a lot of words. Or by loss of triacylglycerols. So if we think about chylomicrons, what's the job that chylomicrons perform? What do they do?
Transportation through the blood.
Transportation. They eventually get to the blood.
Into the blood.
What do they do first? Kind of where are we going to find the chylomicrons hanging out, waiting to do their job?
In the small intestine.
Yeah, in the intestines.
Yeah.
So the chylomicrons are sitting in the intestines, waiting for fat to be digested. Once our body digests and breaks down fatty acid chains, it's going to grab a bunch of them, pack itself full of them, and it travels through the lymph until it gets into the blood, and then it's going to go through the blood and start dropping stuff off and doing whatever it needs to do. Chylomicron remnants are what we get after that chylomicron has distributed and dropped off the triglycerides and like the fats and stuff that it has grabbed and is holding on to. Okay? So chylomicron remnants are the remnants of the chylomicron, what's left over after it's dropped off all of those fats that it's been holding on to. Okay, does that make sense?
Yes.
Okay. Next question. Chylomicrons carry blank in the blank. So dietary triacylglycerols in the blood, HDL in the blood, free fatty acids in the cells, or blood triacylglycerols in the liver.
A.
Just talk.
A.
Yeah, our answer is
Yeah,
going to be A. We just
dietary.
talked about the chylomicrons. Start in the intestines. They travel first through the lymphatic system, and then travel into the blood. And they're carrying the dietary triacylglycerols, meaning what we just broke down in our stomach and in our small intestines to get absorbed. How are chylomicron remnants produced?
Same question, by loss of triglycerols.
Yep.
By loss of triacylglycerols or triglycerides, you can say either one. Okay, now we start to see some enzymes. Lecithin cholesterol acyltransferase, also known as LCAT, is a major component of which of the following lipoproteins?
HDL.
Yep, this one is going to be HDL. Again, this is more, rather than, kind of like an actual, figure this one out, this is more of just the memorizey question of, okay, where is this enzyme located? Okay, nascent HDL does not contain ApoC2 and ApoE. Is that true?
True.
Or is it false? This one is true. Real quick, I'm trying to remember nascent HDL.
Only has, I think, APOA.
Trying to look at
It's
the
a chart in the book.
Yeah, I just want to make sure that I know. Do you know what page that chart is?
In the new version, 69, I believe.
Let's go through, see if it's in here as well.
I'm sending it in the chat here in a second, so you guys
Okay.
don't have it.
Oh, here we go. It's also down in here, HDLs. The first nascent HDLs are produced by liver intestines as a small molecule. Nascent HDLs are discoid and contain less of the phospholipids, APA, and free cholesterols. Nascent HDL right there, right from the book. Nascent HDL does not contain ApoC or ApoE. It contains ApoA. Mature HDLs have more globular, so the nascent means that they're just coming into existence and beginning to display signs of future potential. So these are the new HDLs just when they're produced. When they're mature, that's after the HDLs have flowed through the body and they're picking up cholesterol and stuff from the different cells throughout the bloodstream. So here, nascent HDL it was ApoA is what we'll put in there. Okay, triacylglycerols or triglycerides in serum are transported by which of the following?
VLDL?
Yeah, why the VLDLs? What's the difference between a VLDL and an HDL?
So the HDL has more of the proteins, like and they're smaller. I remember that.
Which is smaller, the VLDL or the HDL?
HDL.
Yeah, so HDLs are smaller. They're made up of more protein than they are of fats. Because remember, we had the little conversation where if somebody has, two people weigh the same amount, but one's full of muscle and one's full of fat, when you put them in water, the one with fat floats because they're less dense. The one with lots of muscle sinks. Lots of protein. Protein is more dense than fat. So our VLDLs, while they are larger, they are less dense because they have more fat. So the triglycerides in the serum or in the blood serum are going to be transported by VLDL. If we switch this question, rather than saying serum, and we said lymph, what would our answer be?
Chylomicrons.
Yeah, then our answer would be chylomicrons. What could be the result of decreased biosynthesis of lipoproteins in humans? Hypertriglyceridemia. Let's go over what each of these means. Hypertriglyceridemia, what does that mean?
Too much triglycerides in the blood.
Triglycerides in the blood. Good. I'm going to keep beating that into you guys. The hypo, all that kind of stuff. Hypercholesterolemia, what does that mean?
Too much cholesterol.
Blood.
In the blood. And then we also have obesity. So the result of decreased biosynthesis of lipoproteins in humans, we would end up with all of those. Because if we decrease production of the lipoproteins, we're going to be having a whole bunch of fat all hanging around in the blood because we're not using it or putting it into anything. So if we're not putting it into lipoproteins, it's just going to be hanging out all over in different places because we have too much excess of it. So we're going to end up with obesity, hypercholesterolemia, and hypertriglyceridemia. Does that make sense? I don't like this question. This is kind of a gross question to me. But does that roughly make sense? Kind of why we picked that answer.
Yep.
What is the major function of ApoB100? First of all, before we answer this question, ApoB100, we saw that a little bit ago in a different question. Where is ApoB100 found?
In an HDL?
Close. It's the VLDLs.
Oh, no, the other
Yeah,
one.
so it's one of those lipoproteins. ApoB100 is found in the VLDLs. Let's actually take a look.
I have
There's
a
high
question
density-
on the
Yeah.
chart I sent. If you look at the APOB 100s, it's VLDLs and HDLs. So could that be a better option if one of those questions were select the best choice answers, or even though he usually doesn't do those questions?
He probably wouldn't ask it that way then. Because see how in the previous question, he had between chylomicron and very low density lipoproteins. So more than likely, like if he had 4 answer choices here, he'd probably put like LDLs and IDL as other choices, or like chylomicron remnants, something like that. If it's true in 2 of them, he wouldn't put both of them there and have you do which is better. Okay. So ApoB100 is in VLDLs and HDLs. So whoever said HDL as well, you're correct. I was mistaken. You know better than I do. Good job. Sorry, guys. Give me 1 sec.
One sleepy pup.
I'm ready to go home, see my pup.
I've been stuck with this one all day. Yeah, and since her mom has COVID right now, I have to be the one to take her to the groomer tomorrow. Because I was exposed to her. So, yeah. That'll be fun.
Fun stuff.
Not too worried about it.
The wife was calling. Okay.
All too real.
If your wife calls, always answer the phone.
Yup. Or if
Okay.
your boyfriend calls.
What is the major function of ApoB 100? It's in our VLDLs and it's in our HDLs. The main function of this guy is going to be our assembly and secretion of triacylglycerols and cholesterols. And if we think about that, if we know it's in the VLDL and the HDL, that makes a lot of sense. So VLDL, a little bit more kind of on the secretion side, and HDL more on the assembly side. Because the VLDLs, you know, if we have a whole bunch of them, it just started raining here. The VLDLs, we can, as we're coming back through, we have a whole bunch of them put together. We can try and drop those off. With the HDLs, we're going to be picking them back up. So assembling them, secreting them, both of those those two factors. We okay with that?
Yep.
What is the major function of ApoB48? I feel like
Cholesterol transport
does that
clearance.
chart actually tell us the function of each of these as well?
Yes, it does. That's why I'm looking down at my book.
Pretty chart. I'll have to add that into my stuff. Okay, our ApoB48 is also same function. Assembly and secretion. It's worded a little bit differently, but yeah. That's interesting, the way that he has it in there. That's fine. Does the same job, essentially, as the ApoB 100. Just the ApoB 48 is located within the kilomicrons. That should be a Y. Unfortunately, some of the other chapters you could kind of have like a good guess of stuff. This seems to be a little bit more kind of, hey, here's a chart, know the chart kind of vibe, which sucks, but it is what it is. What is the major function of ApoC2? This one is going to act as a cofactor and activate lipoprotein lipase activity. Again, this is just more memorize-y, recognize the name, roughly know what it does. Okay, what may happen if the LDL receptor biosynthesis is severely decreased? This is our question that we essentially already had. I think, if not the exact question, very, very similar wording. Who can tell us what the answer is?
Rise in LDLs.
Yeah, because if the receptors are messed up, kind of like what we talked about earlier today with about the same thing having to do kind of with the way type 2 diabetes, you get the insulin, you get decreased insulin receptor biosynthesis with a whole bunch of with type 2 diabetes when you have like less sensitivity to it. And so in order to fix that for treatment is you inject yourself with even more insulin to do the job. What would be the effect of decreased biosynthesis. This is, again, just a repeat question. I like when questions repeat. It makes me feel like we make more progress.
It also makes me feel like he's beating it into us. So, hey, make sure you pay attention. That's on the test.
Exactly. Okay, which of the following apoproteins activates lipoprotein lipases present in the capillaries of adipose and skeletal muscle tissues? And Tony, did you just... Is it because, like, you raised your hands or something?
I just went like this.
I want balloons. Give me
like
balloons.
this. Hold on, oh, like this.
That was awesome.
All right, we'll see if we can figure that out later. Okay, so which of the apoproteins activate the lipoprotein lipase and are in the capillaries, the adipose, and skeletal muscle tissues? If we look at our pretty little chart, let's take a little look-see. Activates lipoprotein lipase, ApoC2, and as if by magic, if we use the exact chart like we're supposed to, that in fact is the answer. Woohoo! I feel like that specific chart is going to be, just from looking at these questions, going to be most of the questions on this chunk of the exam. Which of the following apoproteins guides the chylomicron remnants and acts as a ligand for LDL receptors, leading to receptor-mediated endocytosis? Our ApoE. And also, actually, this gives us a hint as well when it says chylomicron remnants. Because if you remember, ApoC2, ApoE, and ApoE48, those are present within the chylomicron remnants. I don't know about ApoA1. Yeah, ApoA1 is actually only in the HDLs. We know that. Gives us a little bit of an... takes out one of the possible choices. I like that chart. It's a nice chart. Okay, which of the following apoproteins inhibits lipoprotein lipase? And now this is just the other side, inhibiting it. We go back to our beautiful chart. We look at that, our chart. ApoC3 inhibits lipoprotein lipase. Is that our answer? More than likely it is. Yes, it is. Love a good chart. And look, more questions straight from the chart. Which of the following is a specific structural component of nascent or newly formed HDLs? So we looked at that. The only one that was in the HDLs was our ApoA. Which of the following compounds are carried mostly by chylomicrons? Cholesterols, steroids, fatty acids, triacylglycerol, or free fatty acids?
Glycerols.
Yeah, triglycerides, triglycerols specifically are going to be carried by those chylomicrons. Because remember, steroids, if we look at steroids, steroids are a hormone, and those are going to flow freely into the blood. Free fatty acids, those are free. Fatty acids in general, the fatty acids are actually going to be bound to the triacylglycerols. And then the cholesterols, cholesterols are going to be found more within the VLDL to HDLs. Those guys contain those cholesterols. Which of the following does not contribute to lowering the risk of atherosclerosis? We had this was the same question found in actually the previous unit.
Foam cells.
Foam cells. Do you remember what foam cells are? We talked a little bit about it.
sort of.
So give me your best guess. It's
Like-
fine if it's
Like remnants of the fats being broken down in the bloodstream that get like stuck in your arteries.
yeah,
The
they kind of get
foam cells
stuck.
eat it.
Specifically, they get stuck because of macrophages. So
Macrophages.
whenever we have stuff in our body that's not where it's supposed to be, the body has specialized cells that are called macrophages. They're phagocytic. Phagocytosis means like to eat. So macrophages are part of our immune system. So they see that like, hey, there's cholesterol and this other stuff where it's not supposed to be in the arteries. Let's send these macrophages to eat it. And the macrophages come in, they eat the cholesterol, they chew it all up, they digest it, and then they kind of get expanded, they kind of get stuck, and those are foam cells. So with foam cells, you actually get increased risk of atherosclerosis. But statin drugs, our statins are our cholesterol lower drugs. That's a word. That's enough of a word. And HDLs are our good cholesterol. Those are the ones that we want to see. High HDLs are good. Which of the following lipoproteins carries most of the triacylglycerols compared to other lipoproteins as described below? So again, these are going to be our chylomicrons. I don't think I have the picture anymore, but there was a picture that we looked at earlier. So size comparison of versus VLDL. Let's see if I can find it again. Yeah. This picture right here, how much bigger the chylomicron is and how many triglycerides it carries, VLDL, IDL, LDL, and HDL. See the size difference. So our chylomicrons are the ones that carry most of the triacylglycerols compared to the other stuff. Which of the following lipoproteins contain the lecithin cholesterol acetyltransferase, or the LCAT? This is another repeat question. Remember what the answer was?
HDL.
Our HDLs. Which of the following lipoproteins functions as a carrier or as a repository of apoprotein C2? So that's the one that we're looking at, apoprotein C2 and apoprotein E for other nascent lipoproteins.
HDL.
Again, yeah, our HDL. So if we look back in that book real quick, our HDLs had that ApoC, ApoE, ApoD, LCAT, all that kind of good stuff. Seems like for the most part, just again, just that chart. Memorize that chart basically for all of this stuff. Which of the following lipoproteins has the least density?
VLDL. Right.
Chylomicron, wouldn't it be?
Yeah, chylomicron is number 1. That's our least density. Second is VLDL, then IDL, then LDL, then HDL for density.
It's
If
the
we talk
muscle
about
thing.
What was that?
Think about the fat person and the muscle person in the pool.
Yep. I think of that example because my in high school, my older brother had a friend on the football team. His name was Jackson. The dude was like 200 and something pounds of just solid muscle. And he came over to swim in the pool a couple of times, and he literally steps into the water and just boom, straight to the bottom like a rock. Like he sinks so much that like he couldn't even tread water. They just would like he'd kick off the bottom, take a breath, and like start to tread a little bit, and he would be sinking while trying to tread water, because he was just pure muscle. So, which of the following lipoproteins is involved in reverse cholesterol transport?
HDL.
That is correct. Remember that reverse cholesterol transport essentially is mechanism by which the body removes the excess cholesterol from the peripheral tissues and brings it back to the liver. We want those. That's why we like our HDLs. We like high HDL because that means that we're not keeping cholesterol in the blood vessels, especially like the peripheral areas, which can cause some major issues if we get atherosclerosis and stuff, or buildup or clots in our extremities. Which of the following lipoproteins picks up dietary lipids from the intestines and delivers them into the blood circulation?
Chylomicrons.
Chylomicrons. I feel like compared to the other units, this is way more chill.
Mm-hmm.
Which of the following lipoproteins picks up extra cholesterol from extra hepatic tissues?
HDL?
Aisha, what does extra hepatic mean?
Outside of the liver.
Liver.
Yeah, because hepatocytes is our liver. Extra meaning outside of the liver tissues. Our HDLs pick up the extra cholesterol. Which of the following lipoproteins supplies the ApoC2 and ApoE to the newly born VLDLs in order to get mature VLDLs? We think ApoC2 and ApoE. Where are those guys found?
HDL?
Yeah, in our HDLs. I feel like overall, most of these questions is following our trend of figuring out how to best guess. If you're gonna guess HDL. It seems like that's the main one that he likes to ask questions about.
That and chylomicrons.
Yep, HDL and chylomicron. So hey, that gives you a 50-50 shot if those two answers are there. Which of the following molecules is an activator of lecithin cholesterol acyltransferase, aka LCAT enzyme? This again is probably going to be just in that beautiful little chart. Let's see. Yep. Activates the LCAT. So there's actually two of them, the ApoA1 and the ApoA4. Both of those activate the LCAT enzyme. Oh no. So in this case, we only have ApoA1 as an answer choice. Another acceptable answer choice would be the ApoA4. Both of those activates LCAT. And that's just straight from the chart. Which of the following particles is not present in human blood lipoproteins? So immediately off the bat, we look at this. Triglycerides, 100% are in there. Cholesterol, 100%. Apolipoprotein E, we just had like 20 questions specifically telling us that that's in a bunch of stuff. Cholesterol esters. What are cholesterol esters?
They store cholesterol.
Yeah, well, it's the storage form of cholesterol. Kind of like how glycogen is the storage form of glucose. Cholesterol esters is that storage form of cholesterol. Okay? And that as well is going to be in there. So lecithin is our choice. What is lecithin? I don't know, to be completely honest with you.
It's a thickener, actually, in food or for.
It's a thickener.
Yep. Google it.
Lecithin, a substance widely distributed in animal tissues, egg yolk, and some higher plants, consisting of phospholipids linked to choline. Yeah. So it's in stuff,
Just
just
stuff.
not in lipoproteins. Cool. Which of the following pathways is/are also a major producer of NADPH required for fatty acid biosynthesis? NADPH specifically, there are actually, again, the answer is not all of the above, but there are, one of these answers is correct, and then I want you to give me the second way that we get NADPH as well, if you can remember.
So it's pentose phosphate pathway is the one that's there.
Yeah. What's the other way that we get NADPH?
Isoprene?
Starts with an M.
The
Oh,
mal-
the malic enzyme.
Yeah, good. The malic enzyme. There's that process with a malic enzyme that gives us NADPH. So either of these are acceptable answers when we talk about NADPH. Good one. These guys, I promise you, he's probably going to have 2 or 3 questions just like this. He likes these. He does usually put a question like this on the test, from what I remember. Which of the following sequences place the lipoproteins in the order of least dense to most dense? He'll also trick you with this. He'll have one that's talking about density, and then he'll have another question asking about size. Okay? Yep. So remember, those are reversed. So the least dense is the biggest in size. The smallest in size is the most dense. So if we look at these, looking in the order of least dense, so immediately we go through HDL, not the least dense, VLDL, LDL, right here, chylomicron is our least dense. The answer is going to be B. So you just really had to look at the first one to decide. And another one in the order of most dense. So here he flips it, most dense to least dense. Which one is of all of them is the most dense?
HDL.
HDL. So we look at our answer choices. Boom, boom. Those are both gone. HDL. Then chylomicron. We know we just answered chylomicron is the least dense. Can't be that one. So it's got to be that. Bada bing. And that was all of cholesterol.
But what I learned from all of those is memorize the chart.
Yeah, practice that chart, you guys. And I would even, the question that was in here, yeah, I would focus on these sort of questions. And it seems like in the chart, the big things to remember, we'll want to remember the names. You'll want to remember what they're in, for the most part. And then the main functions that he asks about, he's going to talk about activating LCAT, inhibiting LCAT, and then honestly, probably like activating and inhibiting LCAT is what he'll ask. Activating and inhibiting lipoprotein lipase, and then the binding and transport kind of stuff of the cholesterols, whatever the wording of that question was. It was, let's see, which question was it? The assembly and secretion of triacylglycerols and cholesterols. That's the way he'll word that one. So those are kind of like the 3 main groups of things that you'll want to remember.
Yay.
How was that? It wasn't too bad.
Wasn't too painful.
Not at all.
Way
Cholesterol
more
was
bearable
worse.
than earlier.
Yeah. Okay, so good that we were able to keep that one short. Are there any overarching questions or things that you don't feel comfortable with that you want to review pre-test tomorrow?
Maybe quickly the steps of beta oxidation and fatty acid biosynthesis, especially that one, especially fatty acid biosynthesis, because there's more steps.
I thought this would be filled out.
Yeah, what I noticed, Drake, out of your study guides, all of them, they're not filled out.
These ones might not be. Yeah. I've talked about this before. Biochem 2 is a heavy, was like easily became a back burner course, unfortunately. So, okay,
Not a
well,
bad
let's
thing.
mobilize and transport tissue for oxidative degradation. Let's go through and answer a couple of these, and then answer those things that we had in there, and then I'll share this with you guys. Okay. How fats are digested in animals/humans? Roughly that whole process. We're going to be having our lipases, specifically focusing coming from the gallbladder in the small intestine, where they are going to be digested. How the fatty acids are mobilized and transported in tissues for oxidative degradation. We can almost follow the whole process now. So from the small intestine, the chylomicrons, the Y, right? Chylomicrons transport fats through the lymph and into the blood. Through the lymph and into the blood. From the blood, it travels to the tissues it needs to go to. Once in the cytosol, we're talking about specifically for oxidative degradation. Once it's in the cytosol, it needs to go into, where does it need to go into for oxidative degradation?
Mitochondrial matrix.
Yeah, it needs to go into the mitochondrial matrix. Specifically, how does it get there? How does it get into the mitochondrial matrix? Remember? Do we remember?
Oh, it goes into. It uses a carnitine transporter. No.
Yeah, it's going to use our
Okay.
carnitine transporter. Specifically, if it's of a specific size. What's kind of our cutoff for
14.
size-wise? 14,
If it's above
right?
14, yeah.
So if it is below 14 carbon, it can diffuse through. If more than 14 carbons, it needs to use the carnitine transport system. I'm literally just going to throw so this picture right here into there, how this whole thing works. We start off by, we bind a CoA onto, or we, earlier we talked about the, what's it called? The what primes it, the acyl CoA synthase, right? Remember that enzyme that we're talking about? Which is actually one of the enzymes used mostly for synthesase, this acyl CoA synthetase. It's also called a thiokinase. So that guy is going to bind the CoA onto a fatty chain. As soon as it's bound onto a fatty chain, we call it an acyl-CoA. Carnitine acyltransferase 1 is going to bind to, it's going to trade places with that, the CoA. It's going to give the acyl to the carnitine, allowing it to pass through the outer mitochondrial membrane, and then it's going to use carnitine acyltransferase 2 to get through the inner mitochondrial membrane, where then the carnitine hands it back to an acetyl-CoA, or to an acyl-CoA, back to a coenzyme A, rebinds to the coenzyme A to turn back into an acyl-CoA, and then it's inside of the matrix, and then it can go off into beta oxidation. That's mobilization and transported, and go ahead and then next part, demonstrate how fatty acids are oxidized. So step by step, what's our little mnemonic to remind us how fatty acids are oxidized?
That's the D hot, right?
Yeah, D hot, but instead of an O, it's another D. What does that stand for? DHDT. What are our steps?
Dehydrogenase.
Dehydrogenase.
And then hydration.
Hydration.
Another dehydrogenase.
Hydrogenase.
And then that's not another, it's not thiolase, is it?
Thiolase.
Yeah, it's a thiolase transferase.
Thiolase. Boom. We have our whole process right here. Fatty acid oxidation. Just like we said, our step one, we have a dehydrogenase, hydratase, another dehydrogenase, and then a thiolase. We will want to remember specifically what these enzymes are. One sec, let me. I'm going to stop sharing and reshare just because my computer wasn't showing me the bottom of my screen, which was weird. Okay, that I want there. This I want big screen. This I'm actually going to put over to the side because then I can just build on this. Okay. I'm actually just going to go ahead and put these. So we have an acyl-CoA dehydrogenase, enoyl-CoA hydratase, beta-hydroxy acyl-CoA dehydrogenase, and then acyl-CoA acetyl transferase, which is a thiolase. Kind of key thing to remember within all of this, look for the CoA. We're going to have CoA, if you know the steps of each one, it's going to tell you dehydrogenase, hydratase, dehydrogenase, and then acyltransferase, exactly kind of what the order of those are. And then this whole thing is going to be repeated a couple of times. I'm actually going to throw the picture into here. And then these steps are just repeated over and over again until we get to the whole size that we desire for our fatty acid chain. The one that what was the one that we talked about the most? That's like the most common, like if we have to guess as far as like, sorry, I meant, I got put into my brain of synthesis for a second. What's the whole goal of the degradation? What's the goal? What are we trying to produce with beta oxidation of fatty acids?
Some ATP.
Yeah, we're trying to get to ATP, and how do we do that? What do we need to make first?
Acetyl-CoA.
Yeah, we make the acetyl-CoA. That's our whole end goal is acetyl-CoA. So, for example, palmitoyl-CoA, which has 16 carbons, how many acetyl-CoA are we going to get from palmitoyl-CoA?
8.
Yeah, 8. And how many cycles are we going to perform in order to get that? Good.
Yeah.
So remember, so the way to solve for the number of acetyl-CoA is specifically for even number, we just take the number of carbons divided by 2. If we have an odd number, take the number of carbons, same thing, divided by 2, and then subtract 1 from however many. So let's say we had 19 carbon. 19 divided by 2, it goes into it 9 times with 1 left over. So we'd actually end up with 8 acetyl-CoA. And what do we end up with left over? What's the leftover bit, the leftover 3 carbon?
Propanol-CoA.
Yeah, propanol. Also, we also might do a malonyl. Okay, is a malonyl? No, it's a
It becomes succinyl, right?
yeah, but we'll usually call it the propanol. So we have 19 carbon. We get 8 acetyl-CoA and 1 propanol, which is a 3 carbon. Just like that. So that way it all evens out. And remember that the equation for the number of cycles performed. So cycles is the number of carbons divided by 2, again, minus 1. We get that. And those are always, there's always a handful of questions specific.
Quick question, Drake.
Yeah, what's up?
Is the propanol-CoA a 3 carbon?
Mm-hmm.
Okay.
Yeah. Because when we do have an odd chain, we need to be able to have, we need one of them to have an odd number to be able to give us the total number of carbons, because we can't just like poof carbons out of existence. Yeah. Describe how ketone bodies are produced. Let's find that in our.
Isn't it the
But
lack
first of all, we have 3 ketone bodies, right? What are those? Do you remember what those are?
acetone,
Acetone, acetoacetate,
and then
Yeah.
DB hydroxy acid.
beta
hydroxy
hydroxybutyrate.
butyrate.
Good. And here is our formula. And actually, what's kind of cool about this is when you look at fatty acid biosynthesis, you start to see a lot of connections, right? So 2-acetyl-CoA, you use a thiolase to get acetoacyl-CoA. That's our very first step of biosynthesis. And then our HMG-CoA synthase, adding in there as well to give us HMG-CoA. This is all the same up to this point, is the same, exactly the same as fatty acid biosynthesis. And then what it changes is, instead of continuing with the HMG-CoA reductase in fatty acid biosynthesis, we instead use a lyase to give us the acetoacetate, and then we can either decarboxylase or dehydrogenase to give us our other two ketone bodies. As long as we know our fatty acid biosynthesis, we know over half of this whole process. Does that make sense?
Yep.
Sweet.
And Drake, you have a video on YouTube about that, right?
Yeah, I should. Yeah, I have all of first exam, going through the entire book, going through everything, and the Linus questions now for all of exam 1. So it's all there. Let's take a 8-minute break. Everybody breathe, grab some water, and I'll be right back. I'm gonna go. My family wants to show me a couple of things real quick. Okay, I'll be back in at 9. Let's just say about 9:30. If I'm back a little bit sooner than that, we'll get started. Okay.
Sounds good.
8:30 Central.
Yeah.
Yeah, 8:30 Central. Ooh, 9:30 on the dot. I'm back.
Well done.
Can somebody talk again real quick for me?
Hello.
That's better. My audio was weird and just trying to figure out why. Okay. Fatty acid oxidation, continuing down on our ride of the struggle bus. Know the biological importance of fats. So fats are an important source of energy. Obviously, we store a lot of energy in fats. That's our main thing. Has to do with fats as far as this first chapter is. We get lots of ATP from our fats. All this stuff, stripping the fatty acids of electrons, transferring them to oxidizing agent, all that kind of good stuff. The chylomicrons, a carrier of the dietary fats into the blood, located in the intestines, carry the fats to the blood. A couple of details, they are mostly made up of triacyl glycerols, specifically dietary triacylglycerols. The largest in size, but are the least dense of all the lipoproteins. Any other details that we want to include about chylomicrons?
Responsible for transport out of... Never mind, that's the next one.
Yeah. Yeah, and with this, what I'd probably recommend after we finish filling this out and I send it to you guys, if you do anything additional, what I would probably do, open up all of the LINUS questions and Control F these keywords. So like Control F, that's probably super important, but Control F chylomicron, and you could potentially either copy paste the questions about chylomicrons into here, so that it gives you like the key detail specifics, or just like write down what the questions are about and like what like the answers, like key information is. Okay. Now the hormone sensitive lipase, or HSL, mediates that is responsible for fat hydrolysis, and hydrolyses. This is probably supposed to be hydrolysis of triacylglycerols to release fatty acids and glycerol. Remember him really asking any questions specifically about hormone-sensitive lipase? Let me take a look real quick and do exactly what I just said. Fatty acid oxidation and ketones. It's mentioned twice. What is the function of the hormone-sensitive lipase? It's literally right there. And then it's asking about which following compounds can activate the hormone-sensitive lipase, norepinephrine. So we'd go back over here and enter in here. So it's function. And I would probably like highlight that as something as like that comes from a test question. And then norepinephrine activates hormone sensitive lipase. Note that that was also a test question. And even this next question, this next portion, literally gives that answer there. Epinephrine, norepinephrine, and glucagon. Those are the ones that we're going to look at. And then adrenocorticotropic hormone also activates this enzyme, which we don't ever talk about ACTH, so I wouldn't worry too much about that. Okay. Know about the fate of glycerol and free fatty acids produced in this manner through hydrolysis of triacylglycerols. Before we jump too far forward off of this, I'm also going to throw in something that kind of pertains to this chunk that I know he'll ask a question about. And that is the sites of bond cleavage. So this guy right here, sites of bond cleavage, the different phospholipases. This stuff here, let me make sure it doesn't say it somewhere else, phospholipases. And even within the LINUS questions, he has a question or two just being specific about where each phospholipase breaks stuff. So you'll want to remember phospholipase A does the first fatty acid chain, phospholipase A2 does the second fatty acid chain, phospholipase C breaks off the head group, and then the phospholipase C breaks off the phosphate group, and the phospholipase D breaks off the head group. So that's what you'll want to remember specific about that. The fate of glycerol and free fatty acids. Glycerol enters glycolysis. It's not usually a big point. Fatty acids get broken down into our acetyl CoA and then into the Krebs cycle. I don't remember him really having a question about this specific part, but if he does, this is what it's going to be about. It's going to be about something kind of like what's the fate of glycerol? Basically, it's going to go down to that it turns into the glyceraldehyde 3-phosphate and goes into glycolysis. So any questions? I heard a mic. We doing okay? Am I going flying too fast through this?
Good here.
Okay.
Here.
Kind of nice to just kind of get a quick look at everything.
Mm-hmm.
No majority of the fatty acids are oxidized by the beta oxidation process. That's not so much of like something that, we need to dive into, as that's just like the fact. Mitochondria is a site of beta oxidation of fatty acids, specifically the matrix. Remember to review above how it gets into the matrix. Know how fatty acids are activated by acetyl-CoA before they enter the mitochondrial matrix. Does anybody remember the name of the enzyme that activates it by attaching acetyl-CoA?
Acetyl-CoA synthase.
Not acetyl, remember it's acyl-CoA.
Acyl-CoA. Ortho kinase.
Because if you remember, acetyl-CoA is kind of like a very specific. It's that one. It's the acetyl-CoA is that 2-carbon subunit. Acyl-CoA is much more kind of like a broad general term, meaning like a fatty acid chain, some type of chain of carbons that has a coenzyme A attached to it. So this enzyme is going to, we call it priming, prime/activate our fatty acid chain so that it can interact with the carnitine in the mitochondrial membranes and be transported into the matrix. And a reminder that this is an enzyme that starts fatty acid biosynthesis as well. Where does this take place? This acyl-CoA synthetase, where does that take place?
In the cytosol.
In the cytosol, because the synthesis of fats occurs in the cytosol. Here we have again the transportation of fatty acids into the mitochondrial matrix for beta oxidation, aka the role of carnitine acyltransferase 1 and carnitine acyltransferase 2. We already have it up here above. We'll put it again down here below. Let me open back up the questions. Carnitine. Some of the stuff that we'll want to remember. This is a repeat, so we'll get rid of that. I'm gonna tell you, this study guide's way easier to make after I've been through all of the questions recently. Which of the following compounds is an inhibitor? So we'll talk about that. I'm gonna go through, start from number 1. Show these so we can see these together. Every time, so this is what I just Control F to carnitine, and let's look at all of the stuff that carnitine is involved in. So just like we know, carnitine, break this up. Role of carnitine acyltransferase 1, carnitine acyltransferase 2. So carnitine, its role, it's essential for intracellular transport. Fatty acids. That doesn't have anything to do with that. In the mitochondria, as a blank moves from the inner membrane space of the matrix, blanks is transported in the opposite direction. We'll want to include in here kind of a subcategory, fatty acyl carnitine. This is when the acyl group has connected to the carnitine. So when that fatty acyl group, so this is when the acyl group has swapped the coenzyme A for the carnitine so that it can use carnitine acyltransferase 1. Does that make sense? That fatty acyl carnitine, what that is? Okay. There's that part. Transport of fatty acids to the mitochondrial matrix. You're going to require all this stuff. I'm going to add this more under the regulation portion of it. So transport of fatty acids from cytosol to matrix requires ATP carnitine coenzyme A. Keep going. Which enzyme finally releases fatty acyl CoA immediately before the beta oxidation in the mitochondrial matrix? Carnitine acyltransferase 2. This is specifically saying carnitine acyltransferase 2 is the last thing bound to the fatty acyl CoA before it goes to begin beta oxidation. Which enzyme is the major regulatory control point? This is going to be, I promise you this one specific question right here, he's going to put on the test. So carnitine acyltransferase 1 is the major regulatory control point for beta oxidation of fatty acids. Droop will highlight that because that's going to be a big test question. And specifically, then we want to also mark this lets fatty acyl carnitine move from the cytosol to the Antonio, I can send it to you either through GroupMe or something else. Just let me know. As soon as I'm done, as soon as we're finished here, I'll send it to you.
Okay, I'll just put my email. Yeah, sounds good.
Yeah, throw your email in there. Keep going. Major regulatory point. This is added several times. Which functional group of carnitine is esterified with the fatty acids to be transported into the mitochondria? Hydroxyl group. Just add that into here. This is where I'd say just highlighting the whole question. I remember because I made this little joke about mitochondria. Hydroxyl. Essentially, all we're really doing is just putting everything into one place so that it's a little bit more easier to look at. We already talked about this, the 14 carbons. That's not important. Which of the following is an inhibitor of carnitine acyltransferase 1? Inhibitor is our malonyl CoA. It's able to cross the inner mitochondrial membrane during beta oxidation of fatty acids. Good, and that's all that we need to know about the carnitine. And then hopefully we can think activation of beta oxidation. of all that kind of stuff. Activator will be presentation of acyl CoA would be activator to push it through. Okay. Now on to the actual beta oxidation of even chain saturated fatty acids, which is palmitic acid, with special reference to the oxidizing agents used, enzymes, and respective substrates and products formed in the reaction pathway. Specifically, look above for the pictures of the enzymes and the whole reaction. Let's just walk through it again really quick. So we have our, so we said our dehydrogenase, our hydratase, another dehydrogenase, and then our thiolase reactions that repeat and cycle to give us all of the acetyl-CoAs. We reviewed the even number versus the odd number, how that happens. Big things to look out for. Remember the first reaction, this first dehydrogenase uses our FAD plus as a oxidizing agent. Boop, boop. Then our second dehydrogenase uses NAD plus as oxidizing agent. Oh no. I just spilled my water all over the floor. Oops. Okay. The only other part of that you'd really want to look at a little bit more might be kind of these specific products, but I would spend more of your time on the enzymes. If you know the enzymes, like the acyl-CoA dehydrogenase, enoyl-CoA hydratase, the beta-hydroxyacyl-CoA dehydrogenase, acyl-CoA acetyltransferase, if you know those, that essentially tells you what the next things are. It's like the trans deltas to enoyl-CoA, this kind of stuff. The next enzyme, if you know the enzyme, you can remember enoyl. So the second one is enoyl. Beta-hydroxyacyl, beta-hydroxyacyl-CoA dehydrogenase, because it's saying it takes that and it does the dehydrogenase on it. So. No moles of net ATP formed from the beta oxidation of palmitic acid and how to calculate it. I don't remember him ever actually saying this. I think in the book it does mention it. So there's 129 ATP molecules from one molecule of palmitic acid. And so there's 8 acetyl-CoA, which means each of those acetyl-CoA is going to produce in one turn of the citric acid cycle 3 NADH and 1 FADH2, as well as 1 GTP. So if we do some quick math, I don't know where to put my phone. We have, what was it 2.5 was the for NADH and 1.5 for FADH. 2.5 times 3 gives us 7.5 times 8 gives us 60. So 60 ATP from NADH. And then it's 1.5 multiplied by the 1 multiplied by 8. We get 12 ATP from there, another 8 ATP from the GTP, and then we also have production of, during each of these processes, Krebs cycle, and then from the actual beta oxidation, we also form an FADH and an NADH, and that gives us even more ATP to equal eventually to the 129. I don't need to do like all of the. Do I need to do the rest of the calculations for you? He's not going to ask you to do those, so I'm just going to give you the kind of the general ideas. Okay. Enzymatic reaction steps of beta oxidation of odd chain saturated fatty acids and their products, specifically odd chain. This is again of only difference is that the final step gives a, how do you spell that, propanol? The final steps gives a propanol-CoA, a 3 carbon unit molecule rather than an acetyl. And then again, we know we talked about kind of how you get all that stuff. Know the enzymatic steps of beta oxidation of unsaturated fatty acids and the 2 enzymes involved. I don't think he, at least in all the LINUS stuff, I don't think he ever asked a single question about that. But it is right here are extra steps. The enzymatic steps of beta oxidation of unsaturated fatty acids and the 2 extra enzymes involved. Those 2 extra enzymes are I only see, oh, that's what the other one is. Let me re-screenshot that. Our 2 extra enzymes are the enoyl-CoA isomerase to rearrange stuff, and then we also have a different reductase for polyunsaturated. So this is one is for monounsaturated, and the other is for polyunsaturated in order to change the bonds the way that we need to. These guys, again, he never doesn't really ever talk about these kind of stuff, like the alpha, omega, and paroxysmal fatty acid oxidation. This is all that he says about it. Within the book, and I don't remember a single Linus question about any of that specifically going on. Okay, that's all the first chunk. Let me see if I have the rest of the what's supposed to be the study guide, or if I need. Does he still have available the? He should still have like the rough study guide outline.
Yeah, it's on there.
Come on. Looks just like this.
Yep.
Okay, we probably won't be able to get through all of this, but we'll see how much we can get through. How's everybody doing? Everyone doing okay?
Hang in there.
Yeah.
I'm just hungry.
So, cancel. So ketone bodies, in our own words, what are ketone bodies? Easy way to remember that. Essentially, glucose substitutes, and we are in a starved state and need energy for the body. Okay, there's the three of them. Acetone, acetate,
Yeah.
and the beta hydroxy
Beta glutamate.
butyrate.
Yeah.
Clinical conditions that can stimulate ketone body formation. We have diabetes is going to be the big one, as well as starvation state. Those are the main ones that you're gonna see. Let me see if there's any others that he specifically mentions. Anytime there's a high demand for glucose. So think about the insulin versus glucagon levels type questions that he likes to ask. Then diabetes, starvation. Yeah, those are the big ones that he talks about. The next part, metabolic fate of acetyl-CoA if oxaloacetate is depleted. So does not enter Krebs cycle. Instead, it is converted to the ketone bodies in the liver. One, two, three, four. Know the biochemical pathways of ketone body formation, enzymes, and related enzyme catalyzed reactions. I think we already put that picture in here up above. Remember, it's the same as the very beginning of fatty acid biosynthesis. The thiolase, the HMG-CoA synthase. Only difference is that we have here the HMG-CoA lyase, which brings us down to acetoacetate, which is that first ketone body. Last one, ketoacidosis. When the body is out of glucose and is relying on big thing with ketoacidosis, remember the fruity smelling breath. That's the type of the question that he likes to ask involving ketoacidosis, is that you'll have a fruity smelling breath. I'm actually just going to move this up here a little bit so let me save some space. Section 2, fatty acid biosynthesis. We hanging in there?
We vibing.
Mostly. I've been on campus now for 13 and a half hours and I am tired.
No importance of fatty acids and some of their major general functions. I don't feel like we need to really answer that other than, just leaving that there. They do all the different things. Cholesterol, they go towards membranes and energy and all that kind of good stuff. Fatty acid biosynthesis is a reductive process and endergonic. Again, that one's pretty self-explanatory. Know the sources of energy to drive the reactions and the components required for fatty acid biosynthesis. Ooh, fatty acid. Fat fingered the heck out of that. Source of energy is going to be ATP, like it always is, and then the different components. We have OA, and the book has the LINUS learning questions, does a really good job of telling us what specifically OA. We need biotin, we need bicarbonate or CO2, and NADPH. I think those are the main things that we need. There are differences between beta oxidation and synthesis of fatty acids. Main difference, biggest difference that we want to remember is location beta oxidation in the matrix, synthesis in the cytosol. Sources of acetyl-CoA and NADPH required for biosynthesis. The acetyl-CoA, getting from a couple of different places. We can get it from the Krebs cycle, from glycolysis. I think there's one other spot that they specifically mention. Oh, another thing to add up here is manganese. If we want to, here's our nice little comparison between the two. Glycolysis from our pyruvate dehydrogenase. Or also from the beta oxidation of fatty acids. That was the other one. Finally, also degradative pathways of amino acids. Then our NADHP from our pentose phosphate pathway or from the malic enzyme. I think if I remember right, one of the reasons, just kind of looking at this, one of the reasons why I stopped making this this specific study guide was because I realized that he was literally almost going step by step, like through the book main headers.
Yeah, when I looked at it today, that's kind of what it looked like to me.
Yeah, I think that's what's coming back to me. Is then I just erred on the side of okay, I'm not gonna waste my time filling like this whole thing out.
Yeah.
I'm just gonna like read through the book. So the next part, describe me.
Sorry, I was gonna Charlie horse.
Student down, student down.
Ouch.
That's what happens when you don't eat all day.
At the metabolic pathway, how mitochondrial acetyl-CoA is transported into the cytosol, and the role of malic enzyme for NADH production. Metabolic mitochondria is transported into the cytosol. We essentially, that's just like previous material stuff. That's not like, yeah. In fatty acid biosynthesis, successive 2-carbon units of acetyl-CoA are condensed during chain elongation. That's literally just the word for word what it is. What are the sources of first and second carbon atoms during fatty acid biosynthesis? First, from acetyl-CoA. Second comes from the bicarbonate. Literally has it right below.
I almost said something, but I didn't.
Literally a lot of these are just this, like I said, a lot of the same questions
that we've gone through in Linus.
Yeah, that we've gone through in Linus. I'm probably gonna go ahead and stop here. Y'all need to let your brain recoup a little bit, and I think the most benefit's gonna be from looking back at Linus stuff. I'll go ahead and send this out. I'm actually gonna write down. So at this point.
I think there's a ghost in here.
Goes to Dr. Parker.
Yeah.
Or they're just word for word the segments of the book in order. Not a ton of benefit to writing them all here. Best way to view all of these is to crack open the book and follow. Hey, here's a thought. Go watch my YouTube videos where I do just that, and it makes your brain hurt less than doing it yourself.
Thank you,
Facts.
Jake.
Facts.
Definitely.
So true. Literally so true.
Here's the one thing I will say you guys have an actual benefit of being in person. We have perusal, which we have to literally watch this video. I said this earlier. I literally hit play and walk away, and then I come back and listen to the transcription in Minecraft. My brain hurts, but it's not that bad.
My brain hurts, but it's for multiple reasons. So
You also haven't eaten all day.